All right. So today we looked at our air pressure, or on Friday, I know we talked about air pressure. We made a homemade barometer. Right here is a history of a barometer, so it kind of tells you how a barometer works and like what air pressure really is. So today we're going to look at isobars. So isobars are measurements that we look at on maps to determine which way weather's going to flow, and if we're going to have weather or not. So let's go ahead and dive into it. First thing you should do, though, is go ahead and watch this history of the barometer, and just see how that we do end up getting these air pressures and what does it exactly means going on in the atmosphere when we do get those certain types of air pressure. Okay, so right here, we have this guy. And so this is an isotherm map. And so we're looking at the current surface, right? Well, this also says March 6, 2019. So, hey. But anywho, it just gives us a nice little, we have a low pressure zone over here, low pressure, low pressure. And so we see a couple of these low pressure zones, and we notice we see some green and yellow over here. And over here it's going to rain, or it's going to have some hail, or the darker it is, if it starts getting into the purple, then it's going to be some thicker fall, meaning it might be hail or something like that, or some thick snow. So if you're getting some red, yellow, that's rain, but then the darker and darker it gets, that means it's something heavier, something bigger. And then we see these lines, and all of these lines, so like this line that my cursor is on right now, this is all of the same isobar, meaning it's the same pressure all the way around it. And this is a high pressure zone. You notice there's nothing around here. So high pressure areas actually push weather away, while low pressure areas actually pull weather to it. And so that's why we see weather over here by these low areas, or these low pressure areas. Let's go ahead and take a look at what an isobar that we're going to start doing actually looks like. So here we see that this one must be a 1012 isobar map, 1016, 20, 24, and so on and so forth. And so we notice that from this point, it gets 1,000, and it gets bigger going this way. It gets bigger going away from the low. Okay, and so it goes in 4 millibar increments. So what's a millibar? A millibar is another measurement for pressure. So in the past, we talked about pounds per square inch, which is like if you're airing up your tire, airing up a football, basketball, something like that, to get a gauge on. Millibars are how we measure barometric pressures. And so all we're doing really here is it's connect the dots. So we're going to have a map that has none of these lines, but it has the numbers on them. So we have, let's say, weather stations that say, okay, here's the air pressure here, here's the air pressure here, here's the air pressure here, and then we have to figure out this millibar map. So let's go ahead and start on this. So generally when we start on these guys, we're going to find our lower air pressures first and our high air pressures. Okay, so I see 1008, 1008, 1008, 1008, 1008. So anywhere along this line is supposed to be 1008 millibars. And inside here could be anything lower than that. So we have a low pressure zone. Okay, so there could be 1007, 1006 inside of here. We don't know because there's not a value for it, but we do know that this is our low pressure zone. Over here, I see 1024, 24, 24, 24. I don't see any other higher values on my map here, so I'm going to go ahead and put, here's my high pressure zone. And if I see this is 1024, 1024, 1024, 1024. So I can put a circle around that guy. All right. And so generally, I like to start from the lower air pressure first, or the lower air zone first, and then work my way to the higher. Okay, so, and we also go in 4 millibar increments. So this map is nice enough where all of these are in 4 millibar increments. And so I see 1012 here, 1012, 1012, 1012. Come down here to 1012, 1012. And boom. And that makes sense. Okay. Now, something that you got to remember is I've never said this yet, so you are not going to remember it, but I cannot pass from 1016 cross a millibar line to get to this guy, because what that would mean is at this point right here, right, if you were at this town located right where these 2 millibars crossed, that would mean that there's 2 different air pressures there, which is not possible. That's like being in two locations at one time, right? It's just not possible to have two different locations. It's impossible to have two different temperatures for one location, okay? So, cannot cross millibars. These lines will always move pretty much parallel with one another. Okay, so then I start with my 1016 next over here. I follow this down, 1016. Okay. But then I get to this point where I have these three guys over here, 1016. And so I know that anything to the right of 1016 must be lower than, right? So values like 115, 114, 113 millibars, 112 exist between 1016 1012, right? Then from 1012 it could be 1011, 1010, 1009 to 1008, okay? So all of these values exist in between these two isobar lines, okay? So what that means is, could I possibly cut off the circle right here? Yeah, I could possibly do that, but I actually believe it comes over top and connects here and then comes down through here. That's a terrible line. Okay, let me retry that one. Then I come over here and I connect this guy, okay? From here then, I have 120. I connect all my 120s. These guys end up circling up pretty good right here. And so I know that between 116 and 120, there must be 117, 118, 119, 120, 121, 2, 3, 4, and then 1025 could be on the center of here, okay? And so air pressure, if there's high air pressure, we know anywhere if there's a high air pressure, that air pressure will want to be relieved and go from an area of high pressure air pressure to an area of low air pressure. So this happens in this kind of way. So we'll actually get these things that we call mid-latitude cyclones. And so if you guys ever watch the weather in the morning, you may see some symbols like this on the weather where you see this red line with rounded humps. And this means that a warm weather front's coming through. And then behind it is followed up with a blue line that has triangles on it. And this signifies a cold front. Okay, so warm weather or a warm air front means that it's warmer than what's out front here, usually accompanied with moisture and things like that. And we'll get rain and weather out of this kind of a system. And so this system, if you guys remember from our Coriolis effect, we have weather that moves from west to east across the United States. And so this low pressure system will be continuing to be pushed from looks like Ohio, Indiana, Kentucky, and it'll probably be continue to push up here into the New England area, because all of this high pressure system will also end up moving through here through the next couple days. Okay. So anyways, I'm going to explain this. This is called what we call right here a mid-latitude cyclone. Okay, so when we think of a cyclone, we think of it's got this turning rotational sort of motion. And so some people or people around the world, we know our hurricanes as hurricanes, right? And that is a type of cyclone. So a lot of people call these cyclones, or hurricane cyclones, I should say. And in the middle of a hurricane, there's very low pressure. And then as all of this air tries to rush into the low pressure zone, it's just like opening up, like you do the dishes and you start emptying you pull the plug from the drain, and then the water starts bubbling down through the drain, right? And then at the end, the water starts swirling around until it, goes down into the drain. That's what's going on here with this air. Air is going into here, but as it's emptying, right, air's coming from all directions. And as it's going in there, it's swirling. And that's how we get this rotation of this warm air front, and this cold air front is rotating. Okay. And going back to our hurricanes, hurricanes have the same exact motion, except there's a greater pressure difference between all of these points where we have 1008, 1012, 1016. All of these isobars may be very, very close to each other. And so when they're very, very close, that means that we're going to have greater winds, which we all know hurricanes, tornadoes have greater wind speeds. All right, so let's go on to a little more practice. Let's see here. All right, so here's the next one that I gave everybody. I'm going to also attach this. If you can print this out and do this, I'll do a little bit with you, and then I think you should practice on your own. So this one has one low pressure zone. So it says right here, I started on the bottom one. The bottom one's a little easier than the top one. So down here at the bottom, it says start at the low pressure. So here I see 998. 998 is the lowest number on my line. It says go by 4 millibar increments, start at 1,000 millibars. Okay, so start here. Here's 1,000, but here's the thing: is that's the only 1,000 I can find. Well, between 998 and 1,003, right? There must be a weather station out here in the middle of the ocean, and it says 1,003 out here. So there must be a pressure of 1,000 somewhere between 998 and 1,003. There must be a pressure difference between 998 and 1,004. The pressure of 1,000 must be in between those two. Okay, follows it up here and then connects. Our next one is 1,004 because we're going in 4 millibar increments. So I start here at 1,004. I'm going to go on the outside of 1,003 because it goes 1,004, 1,003, 1,002, 1,001, 1,000. I come up here. I'm going to go just below 1,005 because it's not quite 1,004. I go below it because if I go between 1,005 and 1,007, 1,004 doesn't belong there because it should go 1,005, 1,006, 1,007. I go ahead and whoa, my gosh. Sorry, it's a lot easier to do this on the board and not with a mouse. Okay, so there's 1,004. Next, it starts getting a little screwy. I got this 1,008 all the way up here in the New England area. Here's 1,007 down here. Here's 1,009. Here's 1,008. Here's 1,007. Okay, so what the heck's going on? So let's start going here. So as I'm coming down here from New England area, I approach 1,007, which is real close to 1,008. So is 1,008 on the top side of 1,007 or is it below? Well, again, if I look at my 1,005 and I go 1,006, 1,007 must go 1,008. Okay, so I know always on one side my air pressure is growing and on the other side it's decreasing. And again, between 1,005 and 1,012, what's the pressure? There must be a pressure of 1,008 somewhere between 12 and 5. I'm coming up on 1,011. If I go between 11 and 12, there's nothing between 11 and 12, right? So 1,008 must be below 1,009. 8 does not fit between 9 and 11, so I must go below. Connect here with 1,008. I know 1,008 is between 1,009 and 1,007, but I know 1,008 is also less than 112, so I go below 112. So here's 112 right here. I have 112 right here. I know that 112 is higher than 1,009, but it's less than 1,016, so it's got to be in here somewhere. I know 1,012 is less than 113, but it's more than 1,008. I know it's more than 1,011, but more than 1,011, but less than 1,017. But it's awful close to 1,011. Here's my other 1,012. So let's go ahead and start connecting these guys. So these isobar lines, like I said earlier, will pretty much run parallel with each other, pretty much. Okay, so we can kind of see how that guy empties up. Then I have 1,016 here. Here's 16 right here. Let's see, I have 1,013, 1,017, so I know 1,016 goes in between here. Between 1,020, 1,014, there's got to be 16 here. Between 1,017 and 1,012, 1,016 is going to be on this side. So now I begin to connect these lines. So I don't go above 1,018 because 16 doesn't belong between 18 and 19. So it must go below. But then I do know 1,016 does belong between 15 and 18 here. So I will connect this guy. And then I got to finish connecting over here. Then we go 1020. So I know 1020 is between 21 and 16. So I start here. It's less than 24, but more than 16. 20 goes between 23 and 16 here. Whoops. So I go right here, and then 1020 is greater than 19, but less than 24. So I'm going to wrap up right inside here. And then my next 4 millibar increment is 1024. So I'm not going to draw a straight line here. I'm going to circle it up. I'm going to circle it up, and this must be our high pressure region. So what could we expect the weather to be right here? Probably pretty sunny or fairly sunny. Down here, they're going to start seeing some weather. Some of that, here's the warm front coming in, and then maybe a day or so or later on in the day, there will be a cold front coming in right after it as it's moving from west to east, and it's got that slight rotation to it. All right, let's bump up here. This one's a little tougher because I have 2 low pressure zones. I have a low pressure zone up here in the New England area, so 998 right here. There's a low pressure zone, and then I have 999 down here. Here's my other low pressure zone. Okay. So I'm going to go ahead and start here with this 1000. So I see 1000. I know between 998 and 1004 there must be 1000. Between 1001 and 998, here's another one. And so I'm going to go ahead and connect these guys and make a circle around my low pressure zone. Down here I see 1000. Here I see 1000. All right, so I circle that guy up. So we do have 2 low pressure areas that are moving through the United States on this map. Then I see my 1004. So here's 1004 right here. I see a 1003. I also see a 1004 here. I come up here, I see 1004. I see 1004. All right, so this is kind of tough. So looks like to me that I'm going to go ahead and I have 1004 right here. So it looks like this guy might actually do something like this. I'll get a 1004 here. And then 1004 belongs between 3 and 7, I know. 1004 goes between 1000 and 1008. So I'll go ahead. These lines are real close together. They're meant to look close together, not actually be drawn on top of each other. Sorry about that. Oh, that shouldn't have gone through there. Sorry, guys. This is really hard to draw. I want to do it as best as I can. All right. Okay. So there's that. Then after that, I have my 1008. So my 1008, I have 1008 here. I have 1008 here. If I look over here, 1007, 1009. So 1008 must be between here. I have 1008 here. So 1008 must run between 12 and 4. So these guys probably match up here. So here's 1008 as well right here. Connect those guys. 1008 is going to be less than 13, but more than 4. And I'm not gonna come in through here right here because I see this 1008 up here. So I must need to connect. Oh, right there. And boom. I connect those guys or they run off the map. So I see my 1012 right here. So I know 1012 is less than 13, but more than 8. Here's 1012 right here. Here's another 1012. Then here's a 1012 I see over here that takes me that way. 1016 right here. 1016 here. 16 must be greater than 15, but less than 20. Less than 17. More than 13. More than 14. So it's between 14, 18. And that's how they connect right here. Then I see my 16 over here. My next one is 20. I know 20 is between 23 and 19, so it's probably right about here. It's less than 22. Here's 20. It's less than 21, so I'll go below it. It's more than 18, but less than 22, and then I go through 20 here. Then my next one's 24. Here's my 1025. That's the highest one I see, so here's my high pressure region. So I'm going to go ahead. 124 is more than 22, but less than 25. Run through 24. 24 is more than 23, but less than 25. So that's how I end up making that way around. All right, so that's what our second map looks like. So anyways, we practiced these two today. It took a little bit of time. So what you guys are going to be working on for homework is this right here. So you have an isobar map. So you'll have a low pressure region. 992 looks like the lowest one right here, and then the highest is 1028 over here in the New England area. So here's the questions. It says procedure part B. Find the lowest pressure on the isobar map. Did that for you. Construct a 992 iso line around the lowest pressure. Okay. Complete the iso lines in increments of 4 millibars up to 1028. So you're going to start at 992, go to 996. From 996, go to 1000, 1004, 1008, 1012, so on and so forth until you get to 1028. Okay, label the low pressure center with an L, just like we did in the practices, and the high pressure centers with an H. We already did that. Draw the direction of the winds will flow around each of the two pressure centers. So we already saw what I did with the red humps with the warm front and then the cold front with the triangles. We talked about that for a little bit. You guys do not have to do 5. But you do have to do 1, 2, 3, 4, 5. So remember what's going to come through first. The warm front will come through first for number 6. So it's saying that low pressure zone has not reached New York yet, but it will. Right? Here's the low pressure zone, and we know that weather moves from east to west. So this weather zone must then move from here, right, from east to west. Sorry, from west to east. And so it's saying, well, what's going to hit it first, a warm front or cold front? And so it would be this warm front. So what's that weather going to look like? Where's the strongest wind? So the closer these isobar lines are together, the stronger those winds will be. So if I look over here, these isobar lines are pretty close together, or fairly close together. So we'll have some fairly strong winds here because there's pressure change over a smaller distance, and the greater the pressures change over a smaller distance, the stronger the winds. But then if these iso lines are way spread out here, that means that pressure change is spread out over a much longer area. Therefore, we'll have gentler winds. And that's all I got for you today. So let me know if you guys need any help. Bye.